We are here to talk about configuring Appian for scalability and reliability. My name is Brett Shoemaker. I'm the Director of Product Management at Appian. And this is Matt Flanagan. He's the Principal Product Manager. You ever feel like this guy? It can be daunting, right? Let's admit it. It can be daunting to launch an application that's expecting thousands or tens of thousands of users. You might feel like you have a shaky foundation, definitely don't want to be caught scrambling. So we're going to talk to you today about how Appian can scale and the tools that we give you to kind of see what's going on and to analyze where your bottlenecks might be to have better performance and higher scalability. I'm going to talk to you a bit about scaling process, and then I'm going to turn it over to Matt. He's going to talk to you about data. And then we're going to come back to me and I'll talk to you about how to prepare for that usage of that high throughput or high intensity users. So many of you are probably familiar with Appian. You know that the process model is pretty much the key object in almost every application you can build on Appian. And so it's really important that we have a scalable foundation for handling process. And we've paid a lot of attention to that and spent a lot of time working on that. I'm going to tell you a little bit about what capabilities we have. Matt's going to tell you about the process design aspect. So that's not going to be in this section. That'll be in Matt's section. Okay, so first I need to set a little context. This is a graphical depiction of one aspect of our software architecture. These are what we call the Appian Engines. And as you can see, we have a process design engine that handles the actual process model, and the execution engines and analytics engines handle the process execution and reporting. We have a bunch of other engines too that are all also key parts of running Appian, and they're handling different aspects. I'm not going to focus on those today. I'm going to focus on process execution and process analytics mostly. So again, I need to set a little context for those of you who may not understand or may not be familiar with how things work on the back end. But essentially, by default, the default installation of Appian has 3 process execution engines and 3 corresponding process analytics engines. And when you start a process, it starts on one of those process execution engines. And elements of data, some process variables, process metrics, that type of thing, are replicated over to that corresponding process analytics engine. Same happens when you start a next process. So that will start on process execution 2, let's say, and replicate its data over to process analytics for reporting purposes, and so on like that. So we call each of these engines, process execution 1, 2, and 3, a shard. So there's execution shards and there's analytics shards. And the data is constantly being replicated in real time from those execution shards to the analytics shards. So now that you understand this, you can kind of see where we're going here. We have to think about how to scale this, and we give you some tools to do that. And I guess the key component here that I want to make sure you understand is that while these processes are running, we basically get higher throughput by having them run on separate engines. So while it's running, it's taking, some microseconds, milliseconds to run. Nothing else is working on that particular engine at that time. And so that's why we spread it across 3 engines by default. Now, because it's very short and typically there's not a lot of throughput, this is a typical standard install, and most customers are fine with this. But there are a couple of things to understand about scaling, a couple of ways of scaling that I want to talk to you about that improve what I just said, give you more throughput and more read scaling. So the first is read scaling, and the second is throughput scaling. Read scaling is support for more simultaneous queries, so having more reports running, that type of thing, reading more data from those processes that are running. And then throughput scaling is having more of those processes running simultaneously. And it's typically tied up in like write activities, so process state transitions, assigning tasks, executing smart services, and that kind of thing. Now, when you're thinking about how you need to scale, it really is highly dependent on the application you've built. It depends on the process models in this aspect. So here's an example of a very simple process model. In fact, this one doesn't even have very much unattended activity. It has some attended nodes, some some user input tasks that are probably going to be waiting on users a lot, and maybe it writes to a database, and maybe it does a little bit more processing. This type of thing is probably not going to require any kind of scaling considerations. Once you start having many different process models and many different things that you're doing in your application, and some of those are high throughput. That is, they have very few wait times for user interactions. They're doing a lot of processing in the background, a lot of smart services that are unattended and not even interacting with other systems. Those can really benefit from more throughput. You can get a lot more throughput if you design your process that way, and we can scale in different ways for that. So I'm going to tell you about a few of the indicators we have to tell if you're a candidate for read scaling, and then I'm going to tell you how to do read scaling. So read scaling, again, is higher capacity for queries. And what happens is, because that query is running against one of those analytics engines, while that query is running, another query has to queue up and waits for that one to finish. Again, and most of the time, you never even experience any queuing. But there's a log that we have, this engine called summary.csv, that has a column in it called other time, and you can think of that other time just as an indicator of how long a user is waiting for other users' queries to complete before their query can go through. And again, this is by default spread against 3 shards, so the data that you're querying is probably not going to conflict. You're probably not going to be waiting all that much, but when you are, this other time value will go high. And when that goes high, you want to check and see, do you also have a high ratio of read counts to write counts. Those are also in the engine call summary log. And so when you're looking at this data, you can say, all right, well, users seem to be waiting a long time, and I'm doing a lot of reads. Then you're really going to benefit from read scaling. Another thing to point out is, another reason to do read scaling is when you have significant delays checkpointing engines. And I want to clarify that this really only applies to on-premises, and it only applies to a standalone configuration. So that is not a high availability configuration. You have a standalone configuration on-premises, the checkpoint will block while it's doing it, and it can take some seconds sometimes. If those delays start to increase, then you also want to look at read scaling. So how do you do read scaling? Well, it's straightforward. You set it up as a high availability configuration. So this is a benefit of high availability, is that not only do you have data redundancy and continuity of operations, you will also be able to distribute those reads across all of these. So in this image here, you can see the familiar triangles and pentagons and whatnot. That data is actually replicated to all 3 servers, and any of those servers can handle a read call. So at any point, if a user was waiting, they wouldn't have to wait anymore. Now there's going to be another server available for them to get the information. So the other type of scaling I talked about was throughput scaling. So how do you know if you need throughput scaling, and what do we do for throughput scaling? So throughput scaling is, again, your processes are executing. There's a lot executing at the same time. What you're going to look for is a high sustained, like basically pigging your CPU. And so we have a indicator, a metric for this, that's in the perf monitor DB PX logs. There's one of those for each shard, for each execution shard. And so if any of those are showing sustained periods of low values of the CPU idle time, so that is how much CPU is just waiting for work. If the CPU is never waiting for work, then it's very busy all the time. And so you'll be a candidate for throughput scaling. And this sometimes manifests as performance issues, and thinking, well, that process is sure taking a long time. It often you might see it at the server level as well. Okay, the CPU seems to be pegged. What's going on? You can drill down into this file and see what's happening. One important thing to point out, though, is you need CPUs to do this throughput scaling. That is, if you have 8 CPUs and you already have that many engines, you're not going to get much benefit by doing throughput scaling because you don't have the CPUs to support them. So there is a hardware aspect of this to think of as well. I also need to point out, in cloud, you're not really thinking about any of this. We're thinking about it for you. So just a little plug, host your stuff in cloud, and we will keep track of this and make sure that we're able to scale for you, and we'll make sure you have the right CPUs and all of that. So what does throughput scaling look like? Well, it's adding more shards. I talked about those, default 1 through 3. you can add a fourth, a fifth, a sixth. You can go all the way up to 32 shards of process execution engines and corresponding analytics engines. That was new last Appian World. I gave a presentation, actually similar presentation to this, and talked about that. And we've had some customers take advantage of that already. So many went above 16. Some of our customers were at 16. That was the limit previously. Some of them went above that. We saw as we needed to, and there's a couple that are up there at the 32. So it's definitely does great. And what do you get from it? Well, we did a few different studies, a few different tests to see how that throughput might increase. Well, here on the y-axis we have smart services per hour that are being executed, and along the bottom here the number of execution engines. You can see when you have the default 3, we were able to kind of max out around about 500,000 or so smart services per hour, and then of course up to 32 we were able to get over 3 million smart services per hour. So you can also see kind of some diminishing returns. That's basically why we ended at 32. It's about as much capacity that we want to be able to add right now. We can look at that in the future, but again, so far from what we've seen, this has been more than sufficient. So another test that we did that is a good indicator of how you can increase your throughput, process throughput, is the number of processes completed per hour. So across several different tests, we took the average of completed processes per hour by different server configurations. So different iterations or permutations of execution and analytics shards. And you can see the default with 4 CPUs, 16 gig box, the standard 3 Exec and 3 analytics, averaged out at about 170,000, and then all the way on the large end, a big 96 CPU box with 384 gigs of RAM, 32 Execs and 32 analytics. We were able to get, 1.7 million, so roughly. So pretty decent increases as you increase the. And I guess I should emphasize here, this is the same test. So this is the same, just pegging how many processes we can run at a time. And the only variable here is the number of shards and the box we ran it on. And of course, I want to point out that read scaling and throughput scaling work together. So not only can you have multiple servers to handle multiple requests, but you can have multiple shards on each of those servers. So a high availability configuration with 32 execs would look like this. All right, so in conclusion for this part anyway, use read scaling to get more queries, more throughput for reads. You get a bonus here by going to high availability. You'll have data redundancy and have failover if anything happens to any of those physical servers, or virtual servers as it is. And then furthermore, use throughput scaling for more processing. And again, be sure you have the CPUs to support it. There's no point in adding more shards if the hardware isn't there to support it. Okay, now I'm going to hand it over to Matt, and he's going to talk a little bit about data.
Yeah, thanks, Brett. So data is one of the aspects of scalability that kind of hits you later in your program. A lot of people start out with a small amount of data, and then they just add more and more and more and more, and eventually hit some sort of scaling problem. And so I'm going to talk a little bit about some tricks of how to avoid that and not hit the problem in the first place. Data is not a single concept. Appian is a data-rich tool, I guess I would say. There's a lot of different types of data that we can interact with. And I'm going to talk through tips on each one of these things. Process data, relational database data, integration data, which is like calling a web service or something like that, and then how data impacts Appian's web APIs. First, for process. Process variables and all processes in general are stored in memory so that we have very fast access for reporting. The downside of that, though, is that it's in memory. So you gotta manage that, and you can't store everything you might possibly want to store in memory all the time because you'll run out. So there are some tricks that we have that can kind of lower that the used memory without kind of compromising on your reporting capabilities. One of them is there are a lot of pieces of data in your process model that you don't actually care about reporting on. Typically things that are not tied to business events or business data. They're basically internal kind of design characteristics of the model. So if you don't need to report on them, there's this checkbox when you configure your process variable to hide it from the analytics engines, which means it's not going to replicate over the way Brett described. So it's going to use less memory that way. Additionally, we keep a history of every value that a process variable has had over the lifetime of the process for debugging and auditing and things like that. One ramification of this, though, is that if you iterate on a variable many times, we keep a separate copy of that thing each time. So it is basically better to do manipulations kind of all at once if you can, rather than doing it in a series of steps, because then the data kind of moves once, and so you'll have 2 copies of the thing instead of 5. Again, not always possible, but just something to keep in mind if you can. Another trick for process is using subprocesses. A subprocess is a way for a process model to kick off another process model and interact with it in certain ways. Typically, this is like the main use case for this is reusability. If you want a process to do something the same as another one, you can have them both call the same subprocess, and it will it saves you some configuration time because you can just do the same thing. But there are other kind of strategies for using subprocesses that are helpful sometimes, and scaling is one of them. If you kind of move strenuous manipulations into a subprocess, you have the ability to kind of delete that process when it's done and just report back to the parent process the result of that of what you were doing. So you don't have to keep that extra manipulations in memory all the time because you didn't really care about it in the first place, right? This is typically done for integrations because those come back with a lot of data usually, and you only care about part of it. So you can pull in the full thing, extract the pieces that you want, send those back to the parent process, and then delete the big thing that came over the wire. So speaking of this, when a process finishes, there are 3 things that can happen. One is it can delete itself. One is that it can archive itself, which basically allows you to keep the data around for historical purposes for auditing, but it's no longer kind of live in the system. So you can't report on it directly, but we can recover the data if you need it. And the last thing you can do is just leave the process there forever. We don't recommend that one. Typically, you want to archive processes where you care about what happened when and why, and you want to delete processes that are kind of utility processes or things where you don't actually care that much about the details and you don't need to audit it. We allow, on every model, you can configure which of those 3 things happen, archive or delete or nothing. And you get to pick how many days after the process finishes that you want this to kick in. So typically, you'll keep some things around for a little bit of time because you want to see, yes, this did actually happen, or there was a problem here and I want to know why. But the horizon on that's not very long. And then in other things, you want to be able to report on stuff for a long time, and you can leave that around in memory if you need it for the reporting purposes. But most of the time, deleting things or archiving them relatively soon after the process finishes is the path you want to take. And again, this plays back into the sub-process thing I mentioned before, where you can archive off or delete the processes, the sub-processes much earlier than the parent process, the life of the parent process, which again clears out some cruft that you don't actually care about. The second kind of way we deal with data in Appian is relational databases. A lot of people store a lot of data in in the business data source that we provide in Appian Cloud, or in a equivalent thing for an on-prem environment. And I'm going to talk mostly about the kind of Appian-specific pieces of this. There are kind of general practices out there for databases in general, of like putting indexes on columns and things like that. But those are kind of pretty standard, so I'm not going to go into that. I'm just going to focus on the Appian-specific things. The first is that you want to control how much data you bring into Appian when you make a query. We give you kind of pretty granular. You can pick which fields of which table you want to pull back when you're making a record or a sale interface or something like that. It's pretty rare that you need the entire object in the database pulled into the application. at the same time, you almost never show all the things at once. And some of them aren't ever shown anyway, or at all, because it's kind of internal data that like you care about, but the actual users of the system don't. So we have this capability to kind of preview the data you're going to pull back when you design a query. And you can see on the left there, you can select the fields that you're going to pull back, and remove the ones that you don't want. Another thing it's good to do is use the database to do the things that it's good at, and use Appian to do the things that it's good at. So aggregations and filtering and stuff, it's much better to do that in the database usually, because it's designed to do that, right? To filter a query, to only get the data that you care about, rather than trying to pull back a lot and then post-process it in Appian. It works, but it's not as good. Typically slower, typically doesn't scale as well. Use the database for the things it's good at. The other major source of kind of data that Appian manipulates, other than the relational database, is web services. A lot of enterprises out there have a host of different web services, both REST-based or SOAP-based, or some other thing that they made up. And Appian can interact with that data in a variety of ways. The main object that we use to make these interactions is called an integration object. And it basically is a wrapper around an HTTP request. So you put in the URL you want to go to and query parameters and stuff like that, and it will reach out and pull some data back. The best practices here are actually very similar to the ones with the database. Let the service do the thing that it's good at, let Appian do the thing that it's good at. Only pull back the data that you actually care about in your system if that's possible. Not all web services provide that sort of capability in filtering. Sometimes you just have to get the data back and then you need. Or you have to get all of it if you want any of it. But if you can filter it, do that. If not, and you have to get all of it back, go back to the sub-process thing I mentioned and kind of do that separately, pull the data in, filter it or whatever, and then purge it out. We also have a little bit of protection here of you can set a timeout on the request. If it's going to take too long, we will kill the request and not pull the data back, which is helpful for you made a query that accidentally didn't filter something or something like that. And this is a protection for the system that you don't have to worry about that sort of thing crashing your computers. Appian Web APIs are kind of the opposite side of this, where Appian exposes data or the ability to pull data in to another system. So again, the practices are similar to what I've been saying before. You want to only kind of ingest the data that you actually need in order to make the update that you're making. You don't want to just pull in all the data or get pushed all the data, really, when you don't need it. And if you are exposing data out to the outside world, you want to provide paging controls, you want to provide filtering controls, all the things that you would have wanted on your web service that you're calling. And Appian lets you do that through the queries that we talked about earlier. Speaking of extracting data from Appian, a very common case for us is someone just wants to give me all the data in a CSV, right? I don't care about big integrations or whatever, I just want to see the data. So we've kind of made that very easy for you. This used to be possible only really through a plugin, but some of the plugins were not written very well for scale, and they would pull in all the data from the database at once and crash the system. But that's not the right way to do it, right? You want to pull in a little bit, write it to a file, pull a little bit, write it to a file, and then sum it all up at the end. And so that's what this capability does. We have it in two different places. One is on every record list. You can check a box, and if you do that, all users can download the data just kind of at once without you having to do a lot of work and without a threat to the system, because we stream the data rather than do it in one big batch. We also have the ability to do this through a smart service. If you want it programmatically, like grab all your data every night and archive it off somewhere or send it to another service, you can automate that process with the Appian Smart Services. The last thing, this applies to cloud customers only. We provide a business data source when you get an Appian Cloud instance and a relational database. And people store their data in there, but they want to hook it up into their larger enterprise, right? They want to put some BI tools on it. They want to run some ETL on it or reporting or whatever it is. And so if you are on a Premier support contract for Appian Cloud, we will let you open up a connection from your enterprise directly to that database where you can do that sort of manipulation. Okay, and now Brett's going to talk about how to scale up your Appian program in general as you add more users and your users start doing more things.
Thanks, Matt. All right, so now we have, between what I told you and what Matt told you, a pretty solid foundation. We've got some steps that are no longer crumbling, but now we have a user with a giant success boulder on her back, and she's got to somehow use our system, right? So this is a metaphor, of course. Think about your thousands of users that are going to hit the system. How are we going to be ready for that? We think we have the foundation solid, but are we sure? Well, the most important thing is load testing. I've talked to a few of you. I'm not sure I actually see you in the audience right now, but I've talked to many of you already in this conference, and we've talked about how to make sure that you're actually load testing in the way that production will run. And so there's really there's a few key components here. You want to make sure you have representative data sizing and data shapes. So the data itself that's either in Appian Engines or in the relational database should resemble what you have in production. You might do that by backloading data from production or by fuzzing the data and saying, okay, we're going to probably expect to have 1 million rows in this table, and it's going to be average size of this. So it's important you get that in place for your load test. Another important aspect is making sure that you're load testing with the number of users that you expect to have simultaneously. And by the way, part of load testing is pushing that boundary and seeing where the load limits are. So you may do multiple iterations of load testing, first with maybe just 10 simultaneous users, then to 100, then maybe 1,000. But be realistic about how many people will actually be using your system at the same time. We have also seen load tests that grossly overestimate how many users they have. And as expected, you may not get the performance, or you might prematurely want to scale up when you don't actually need to. And then the other important aspect that kind of goes hand in hand with understanding how many users you're going to have is what are those users going to be doing. We've worked with customers in the past that didn't build in wait times, for instance, in their load testing. So that's not really how users are going to be using the thing, or it only load tested one process, one of the actions in their application. Well, okay, there's like 10 other actions, and maybe there's 5 tabs to go to and do different tasks. And so think about it. Draw yourself a diagram like this and say, okay, well, this type of user is going to go in and do this, and the result of their activity is going to be this output, and therefore, another user is going to come in and take that output and do it. Try to set it up to match realistically what you expect your users to do. One other hint on this is double check and make sure that your users are getting individual sessions. So sometimes with load testing tools, you'll capture the session token, and now every user appears to be that same user when you're running through the load test, and that's obviously not realistic on both ends. Sometimes it can lead to worse performance than you would have in real life, and sometimes it can lead to better performance than you'd actually have because certain data may be cached and not have to be retrieved again. So plan your load test well. Okay. Now, once you've done your load testing, how do you identify the hot spots? Like, how do you identify what you need to improve? In 19.2, we have a new feature, record response times. And this feature is a great monitoring tool that will show you every user whose interaction with a record took more than 3 seconds. And we'll aggregate those, we'll keep them for about a 30-day moving window, and we'll show you the top 10. This is useful for load testing, right, in your staging environment or whatnot. But even when you're in production, you'll be able to look at this and see, okay, let's see, Abhishek reported that something was really slow for him. Okay, well, I can go and see, all right, he said he was on the sales and marketing. Oh yeah, it was slow, it was 28 seconds. And from here, I can drill down and see why. So we not only show you how long it took to do that interaction with the record view or record list, we'll show you everything that happens. We capture the actual performance view. So you may be familiar with this if you've used Interface Designer and or the Expression Rule Designer and switched to the Performance tab there. It shows you kind of in design time how long everything's taking. But we're actually capturing that now in real life, for real life users, and capturing all those metrics. So we can say, it works fine for everybody, but for whatever reason, poor Abhishek's having a terrible experience. What happened? Well, we can look and see, oh, okay, it turns out that this call to an external service is slow for him because he has higher permissions and therefore is bringing back more data. We didn't expect that, something like that. So that's a great tool. So you can drill down, again, from the record response time. Each of those timing items there is a link, and that'll drill down the performance view. The other thing I wanted to point out on this is we'll rank all of your record UIs by how bad they are. So we can see, like we have a red frowny face for the ones that are performing the worst, kind of a neutral face for those that are kind of borderline, and then a happy smiley green face. Obviously your goal is to get to all happy smiley green faces if possible, but there are some times where you're talking to an external system or something that takes a lot of processing where you don't have that expectation. But this will give you that real life view. Again, both in load testing you'll use it, and once you're live and actually trying to see how the system is working. Furthermore, we still have rule performance metrics, history, a whole history of them. So we not only capture the slow ones and bring those to the surface. For any interface or any expression rule, you can drill in to the performance history and see how it behaved over time. So this is really essential when you're load testing. You can see, okay, here's how it performed on the run that we did March 31st. Okay, we made some changes. Oops, we actually made it worse. On the run that we did on April 4th, it was actually performing a little worse. And then we made some changes again, did another run, and we can see, okay, we got some improvement. And that's how you can kind of hone in on the changes you need to make to your rules, your expression, your interfaces and your expression rules to have the best performance possible. Another thing I want to describe is some stuff that we do behind the scenes for you. This isn't something you ever think about as a designer of an interface, and it's parallel expression evaluation. So we can detect where we can do parallel evaluation, and we'll do that. So in this example, just to explain what you're seeing here, imagine that this represents a graphical representation of executing a rule that populates a list of account managers that don't have accounts. Okay, and so the evaluation time is going from left to right here in this picture. And so first thing you need to do is, okay, let's get all of our customers, okay, and then let's get all of our account managers and see, which account managers aren't lined up with the customers, and then we can display those. And what's happening is everything that you see stacked is actually executing simultaneously instead of serially. So that's a performance boost that you get just by using Appian. And I pointed out because this is rare. Typically, in traditional software development, you have to think about how to do multi-threading and concurrency, and it's a real nightmare for developers. This is not a nightmare for any Appian developer. They never think about it. It just happens automatically. Another thing that's new, we came out with this year, it's actually already on every version from 18.3 and later, is the expression memory circuit breaker. And so what this does is protects you against those wild hair, runaway, crazy expressions that somehow blow out memory. And probably at some point in your Appian experience, you will have run into this. And it's typically an accident, right? I didn't filter when I should have, or again, Abhishek happened to have higher permissions, and so therefore he was pulling back way more data than anyone else. And so what we'll do is we'll detect this now. We'll track memory, and if there's an anomaly, if there's a huge jump, we will halt that single expression before it can exhaust memory, protecting the rest of the system. So that expression gets halted, but the rest of the system survives. No one else, maybe that one user gets an error on the screen, they come back and try again, maybe it's fine, or maybe every time they do it, they see the error. That lets you drill down and fix it for that one user instead of having a system now that just exhausted the application server heap and you have to restart the app server. So big improvement there. And again, that's on all versions from 18.3 and later now. One important thing to point out for those of you using plugins, you really want to be wary of how those plugins do memory management. We can't apply this expression circuit breaker to plugins, unfortunately. So those are not halted by the circuit breaker. So just be extra conscious. If you're using a plugin that manipulates data, pulls data from another system, writes data to a file, that kind of thing, those are not going to be halted by this. So you need to pay special attention to make sure that that's memory safe there. Okay, and then I want to finish out by just, again, going back to the high availability. And I pointed out earlier when I talked about the process scaling, how you get read scaling and you can add shards for throughput scaling. That doesn't just apply to the engines. In a high availability configuration, sessions are load balanced across application servers. So if you had one application server in your standalone, when you're in high availability, you have 3. By the way, I'm not sure if you can see it there. It looks like 2 boxes, but there's just the third one's just hidden behind there, so it's not too redundant. And so now you're getting all that extra computing power across 3 different servers, in addition to, of course, the failover and data redundancy aspects. And that's also true for everything else. So the engines also read scale, the data server read scales, and the search server. We have read scaling on all of those elements. So high availability really is the first answer to higher capacity. And if you're in cloud, that's available with Premier support. So you just get high availability when you have Premier support, and you'll get all of these benefits that I'm talking about. Okay, so to summarize, there's a few things that you can do to get more information. We talked about process and how the process engines scale. Matt talked about how to design your applications to handle data. And then I talked a little bit about load testing and looking at usage. Well, there's a ton of docs on all these things. So there's on docs.appian.com, there's a page called Scaling Appian. That has a lot of information. There's actually an academy course called System Architecture, and that'll show you a lot. Of course, load test your applications, like I said. All the things that I said and more are in our best practices, which is also available on the Appian playbook, so you can get to there from docs. And of course, ask your account exec about going to Premier support in cloud. All right, thank you very much for your attention and your time.